The idea of a lunar rover predated the Apollo program by like a decade. I mean, Wernher von Braun, the father of rocket science, mentioned it in one of the magazines in 1952. In an article titled Man on the Moon, he imagined this 50-man, 6-week-long expedition to the moon in the next 25 years. He talked about all the dangers, invisible tissue damage in cosmic rays, meteorites, huge crevasses beneath thin layers of crust, jagged rocks that could pierce the spacesuits, and so on. He also talked about how the mission will go in general, all the details. And he also talked about quote-unquote tank-like cars equipped with caterpillar treads for mobility over the moon's rough surface. These vehicles will have pressurized cabins that will be able to hold up to 7 men, some radio equipment, radars for measuring depths and distances, and a 12-hour supply of food and oxygen. These vehicles, I believe he also called them tractors, will have a top speed of 40 kilometers per hour. Not that bad. And yeah, they will help to explore the moon, the lunar surface. The idea of a lunar rover was also mentioned by a couple more people throughout the 1950s. So yeah, scientists were thinking about that for a while. However, the final version of a lunar rover turned out quite different from what they had originally envisioned. You should understand that initially the idea was to use 2 Saturn V's for each mission. One will carry astronauts and a lunar module, and the other will carry a lunar rover and equipment. So they could afford a lunar rover to be big. But even with more smaller designs, the concepts, the scientists still thought it will be a dual launch. And maybe it will have been. But Congress started pressuring NASA to hold down the Apollo program budget. So they had to put the dual launch idea to rest. So yeah, now they had no choice but to design a very compact and light lunar rover, the one that will be able to fit in one rocket, with astronauts, a lunar module, and equipment. And they built this. I mean, just look at it. Look at this beauty. It's... wow. There is something special about this image. An astronaut, no, a human, riding a vehicle on a celestial body 360,000 kilometers away from Earth. That's... that's crazy. Anyway, let's talk about how it worked. Let's start with the wheels. I think it's the most interesting part. Choosing the right wheels, the right tires was very important. I mean, for starters, the temperature range on the moon is extreme. It can get as high as 120 degrees Celsius during the day and as low as negative 130 degrees during the night at the equator. And on the poles, it can get like negative 250 degrees or even lower. In other words, yeah, it's very extreme. Then, you should consider how rough the surface is. Like, not only there are a bunch of craters and mountains, but also a bunch of extremely sharp rocks. That's why, for all those reasons, you won't be able to use regular rubber tires, so they had to design something else. The problem though is that NASA, at that time, didn't really know much about the lunar surface. We know a lot now, but back then, the NASA, all they really had were like pixelated images from the probes. And that's kinda it. And of course that complicated things. The Marshall Space Sciences Laboratory was responsible for this. And they set up a test area, like a bunch of test tracks with craters, rock debris, all of that stuff, where they tested all kinds of wheel designs. As you already know, it was important for wheels to have the ability to withstand extreme temperatures, be able to climb craters, mountains, all of that stuff, and be resistant to punctures. Oh, and also, the lunar soil is very soft, so it was also very important that the wheels wouldn't sink and get stuck. Not the easiest task, I know, but I mean, so many things. But eventually, this was the final result. Aren't they beautiful? I don't know how to explain it, but I mean, I just like them for some reason. So if you look closer, you can see that they're actually translucent. That's because they were made of a woven mesh of zinc-coated piano wire, and then they also had these titanium chevrons on the top for traction. And underneath was this aluminum skeleton, which you can see. It was an incredible design, and it even exceeded expectations. Like, the wheels were sinking much less in lunar soil than they initially expected. And then this mesh, it was kinda deforming over rocks and then bouncing back like a spring. So yeah, it was a good design. Each wheel was powered individually by a 1/4 horsepower electric motor. Yeah, you heard me right. A 1/4 horsepower electric motor. So in total, the rover had 1 horsepower. Just one. I mean, they might as well just send a horse and put it in a spacesuit. But seriously though, the gravity at the moon is just 1/6 of Earth. And you don't need to worry about aerodynamics and all of that stuff. Oh, and also, the rover was fairly light. Like, it weighed just 200 kilograms on Earth without payload, which is already light. But on the moon, it weighed just 34 kilos. And even with all the equipment, astronauts, cargo, all that stuff, it still weighed less than 100 kilos. So yeah, pretty light. The rover had a top speed of 13 kilometers per hour, although one time it even reached 18 kilometers per hour. I mean, you can say that it's kinda slow, but even if it will have a higher top speed, you still won't really go that much faster because of how much rough the terrain is. Oh, and by the way, an interesting detail. So, as I said, each wheel was powered individually. But what if one of the motors will fail? Well, in that case, they could just disengage the drive from the wheel and allow it to spin freely. It was a very great design. So, electric motors. How was it powered? It was powered by two 36-volt silver zinc batteries. The rover had a range of 90 kilometers, which is not that bad if you think about it. However, these batteries weren't rechargeable. I mean, you could recharge them for like 10 to 50 times, but it's not that much. Now, let's talk about steering. As you might have already noticed, the rover, it didn't have a steering wheel. Instead, there was this T-shaped stick, like the kind you see in airplanes. You move it forward, and the rover goes forward, left and right for steering, and then backward for brake, and all the way back for the parking brake. And you could also press a button and go in reverse. Very simple. And then that stick, those buttons, it was all designed so that astronauts will have no problem operating it with thick gloves. Actually, when they were developing the lunar rover, they put one of the prototypes into a KC-135 plane that will go in this it's called a reduced gravity parabolic maneuver. In simple terms, it was simulating weightlessness, like 0 Gs on Earth. And during this test, they realized that the astronauts had a hard time using the controls, so they had to redesign them and train the astronauts more. Also, during this test, they noticed that when the rover was driving, it was generating too much dust, so they put these fenders. The dust problem, well, first of all, it's very abrasive, so it can damage the suit and the equipment, and it's bad. And then, since it's dark, it absorbs a bunch of sunlight, which results in overheating. So fenders were a must. During Apollo 17, one of the astronauts accidentally broke one of the fenders, so they had to fix it right on the moon. At first, they tried to duct tape it, like with this gray American duct tape, but it wasn't sticking very well because of the dust. And after 1 hour of driving, they lost the fender. So they had to make a new fender out of laminated maps and duct tape. And this time it worked, and actually surprisingly well. So yeah, fenders were very important. Okay, let's talk about navigation. Keep in mind that on average, each lunar rover was driven about 30 kilometers each mission. It's not that much, but they still needed navigation so that they will know where the lunar module was, and so that they will be able to come back. So for navigation, they simply recorded the distance and direction by using an odometer and a directional gyro. So yeah, this lunar rover, it's an incredible piece of engineering. Like, I just can't stop looking at it. Every piece of it is just... it's incredible. And the coolest part is that they obviously left them on the moon. Like, they didn't take them back to Earth. So the next people that will go to the moon will have a chance to see them in person. But even on Earth, the next time you look at the moon, always remember that those rovers are there, sitting on the moon, and a bunch of other equipment. Just 100 years ago it was pristine and untouched. And now there's a human equipment. That's so cool.